I'd like to thank Joe for inviting me here and for having faith in this sort of out-of-the-box idea. I'll just get straight into it. A lot of you might have seen the headlines this past week or so that fresh water that, well, I'm not saying fresh water, but water that renews itself has been found on Mars. Has anybody seen that? Yeah, okay. NASA have announced this, and they've also said we don't know where this is coming from. We don't know how it's renewing itself. So hopefully by the end of this presentation, we'll discuss a possible source of water on Mars and why, from my perspective, this was expected. So in this talk I'm going to do, first half I'm going to do a unifying principle which connects black holes with other levels of the universe, give examples, some predictions, and then I'll explain the connection with water and then give some examples, predictions and possibilities for the future. And I've had to leave out lots because to fit the time, so this is much, much simplified. So the whole story for me started with looking at microquasar behavior. And microquasars are it's sort of a smaller, supposed to be a smaller version of quasars. And there was some very interesting behavior that was found in microquasars. And so, for example, electrons at nearly light speed, and microquasars are associated with black holes. So electrons at nearly light speed in narrow jets, and positrons, so antimatter informing positrons, and gamma rays. And these were being ejected in the vicinity of microquasars in narrow jets periodically. And I thought, this is kind of strange, because aren't black holes supposed to be sucking everything around them? So how is it that microquasars are giving off all this material and in narrow jets, and it's not all getting sucked up by the black holes? And Sir Martin Rees at the time said we should study microquasars because basically black holes at different sizes behave in the same way. So if we understand about microquasar black holes, we understand about the whole black holes in general. And so the traditional picture, as you probably know about black holes, is that they suck up everything around them. And they're supposed to be rare, they're supposed to be the end points of stars that collapse into infinite gravity and suck everything. Has everybody seen the movies? Yeah? They're going towards the black hole in the movie. It's always a black hole, isn't it? And so that's a traditional image, and many a science fiction plot has been created out of it. But what people were not expecting was to find that black holes are actually everywhere. And this is what we started to find, and I'll just play this clip.
One by one, we were seeing this picture sort of emerge out of the fog that every galaxy, or almost every galaxy, had a supermassive black hole in it. It was really quite astonishing.
Far from being rare freaks of nature, the nukers began to suspect that all galaxies could have giant black holes at their hearts. If this was true, it would revolutionize ideas of what a galaxy actually is.
Thank you. So this is strange. So how is it that black holes, which are supposed to be rare, are at the centre of every single galaxy that we look? And we didn't know that this was going to happen. It's even one, as you probably know, at the centre of our galaxy. So over 10. Oh, hello. Yeah. Hello.
One, two.
Okay, so over 10 years ago now, that's better for my voice as well, I had a massive insight as to how this data all fits together. And so what I've been doing over the last decade or so is accruing sort of different evidence for this pattern being correct, but what is correct in science, but anyway. Just to really simplify things, what I really realised is that at the speed of light, essentially, what you have is a splitting of photons at the edge of a black hole into matter and antimatter, and they also kind of breathe. You might recognise this from the 0-point field, sort of. The photon also, it splits into the electron and positron, but also goes back into the photon again. So that's the insight that I had. And so this is it again. So this is essentially what has been called the black hole principle. So that's why we see electrons speeding out of black holes at almost the speed of light. So this is what we observe. And they're doing that because they've only just finished with this process. They're only coming out of the edge of the black hole. And the recombination process happens as well to combine to form the gamma ray burst. So I call this a type of breathing process where one way it goes towards the matter and antimatter, and one way it goes towards the gamma ray burst. And I'm saying it happens at every level of the universe, but the particles and the radiation might differ. So this insight is interesting, but it's nothing without data, so it must have observations and ideally make predictions to back this up. So that's what I've been doing. So this is really, really simplified. I'm just going to look at just a few aspects of what we should find at the different levels. One is bipolar concentrated jets, and the most important thing is that it's actually concentrated, so which we'll come on to later. There's fluctuating unpredictable emissions, so sometimes gamma ray bursts go for days, sometimes hours, so that's the sort of thing that we should be finding. Emissions of greater power than expected, because what we're dealing with is acceleration, not acceleration, but we're dealing with actually deceleration, because the electrons are decelerating, but it's almost at light speed, and there's often several types of emissions. So the presence of gamma rays, antimatter, and usually electrons in magnetic fields, X-rays, so this is the sort of pattern that we should be seeing. One of the things that really made me realise that something might be in this insight that I had was to find that there's an antimatter fountain coming out of the Milky Way, which was discovered in 1997. And so I just sort of went, okay, let's keep looking, there might be something in this. And so this is too much to go into in this presentation, but one of the signatures of this process is the bipolar jet, which you see around galaxies quite commonly, and also note that people at the moment think that the bipolar jet is created by the accretion disk. Has anybody heard that? Yeah? A few people. Okay. Now, so they say that basically the black hole is sucking things in, it falls on the accretion disk, it gets heated up, and it spits out material in a bipolar jet. That's, if you ask a lot of physicists, that's what they'll say. Now, I have been in physics meetings where they have tried to make this happen and tried to say, well, why isn't it not just flying off the edge of the accretion disk? Is it spinning? Why is it not just flying off the edge? Why is it concentrated in these very narrow jets and going so fast? And you have to do a lot of mathematical contortions to make that happen. It's not simple, it's not elegant. So it's been a puzzle to a lot of people why these bipolar jets occur. Because they're trying to make them come from the accretion disk and not from the black hole itself. So this is one of the signatures of the process. And as you can see from this slide, there's another bipolar jet. But in this case, this is not actually a galaxy, this is actually a star. You even get bipolar jets on stars, and you also get them around planets. So one of the signatures is that you get this bipolar outflow, and as we've known for some level, you do get bipolar jet flow at the quark level as well. And as I said, there's this breathing process. It doesn't just produce matter and antimatter at the edge of a black hole. It also breathes, and it's also recombining to form the gamma ray burst. And at this point, you're thinking, this lady is completely nuts. Why would a black hole breathe? You know, she is making this up. Well, actually, we have found galaxies do indeed breathe. And so these studies with high velocity clouds, and so the galaxy is breathing, pushing out gas, and as if exhaling and inhaling. Okay, so this process is going both ways. So, okay, so this was a surprise to when they discovered it with the Fermi telescope in 2010. Wasn't a surprise to me at all. I was expecting this to occur. This is our own galaxy. Has anybody seen this picture? Yeah, some people, some have. Right, okay, so you probably can see the bipolar jets here. Okay, and so these are gamma ray bursts that are coming from our own galaxy. And so what I'm saying is a part of this process. And these were unexpected. People didn't expect to find this. And if you remember what the headline was our galaxy is blowing bubbles. You know, because when there's something that's unexpected, they start to anthropomorphize sort of objects in space. And if you remember, I don't know if anybody does, but they said that this is a process, these bubbles here, are a shadow of an explosion that happened many millions of years ago. I don't think that. I think this is the same process. I think what's happening is these bipolar jets have been produced by our own galaxy, and as the galaxy rotates, it produces these bubbles. Okay, I think this is an ongoing process, not a process that happened millions of years ago, and we're not looking at a ghost here. This is a living, breathing process. So just recently, in 2015, we've discovered that these jets are actually creating winds at 2 million miles per hour. Okay, so and again, they are saying that the galaxy is hiccuping because there's no mechanism for this yet. So, okay, so. Then, I just wanted to say, because a lot of people say that gamma ray bursts are produced by explosions, and that's not what we observe in the patterns of gamma ray bursts, and that X-rays are produced as a sort of afterglow. What we really find is this oscillatory pattern that kind of seems random to us. Sometimes they'll just, be very, very bright for a while, but an explosion will be very bright and then it'll die away. What we observe is very different. So we see these gamma ray burst repeaters, we see gamma rays, X-rays, gamma rays. So it's more in keeping with this breathing pattern that I'm talking about. It's not so in keeping with a violent explosion. Okay, so the data doesn't fit the theory that they're putting out. It fits better the idea that there's this breathing pattern at the edge of the black hole. So because of this X-ray repeaters that come up, they've decided that black holes actually burp. There's this tendency, as I said, to make black holes burp, hiccup, anything, as an explanation of why it is that they're doing this, because they still believe that what's happening is the black hole is eating everything around them and spitting it all out. So they say these terms like hiccuping and hiccuping and burping. Right, so, but how does this relate to anything to do with us? Is this actually happening at different levels? Well, I think it actually happens in our solar system as well. And so this is our own sun, and we see the same pattern that we see antimatter particles coming from the sun. As I said, I haven't got much time to go into how they differ at every level, but this is a wonderful picture of an actual gamma ray burst coming from our sun that was so bright that it actually lit up the whole picture, which is amazing. which is very rare for it to be so bright. But we have gamma ray bursts, we have antimatter, and we have X-rays, we have fast-moving electrons at the speed of light coming off the sun. So we have the same kind of process. We say have the same kind of pattern that's going on. Whether it's the same process, I'm not saying, but I mean, you know, I think it hints to the same process. Now, our planets as well. As we know, Jupiter has, well, a lot of the planets produce these enormous flares from time to time. And people don't understand it because planets like Jupiter are supposed to be too far away for it to be a reflection of the sun. So, as you can see, nobody really knows. Scientists are baffled as to where the energy is coming from. What I'm saying is that this is the same process happening in Jupiter as well, and it's just at different levels. So that's where you get this enormous flare with the high energies that's giving out by this process. And as we know, Jupiter lost a stripe temporarily, and it came back again. So that's that fluctuating pattern that I was talking about. Now there's a big, there was a big surprise when we looked at comets, because comets actually give off very, very fine jets too. Totally unexpected, and they're actually in the side away from the sun. So here you have the fine jets again, and I know we've got a lot to get to the water, so and I'm really not going to go into this, but I mean, we've got to revisit the atom processes as well. You know, you have the gamma rays and in radioactivity. So does the Earth show these behaviours? Well, surprisingly, there's quite a lot that fits the pattern in our own planet. And so, you know, for many years we haven't known anything about the interior of the Earth, but now that we're actually getting data from the interior of the Earth, we know very little about it. We're actually finding antimatter from the interior of the Earth, geoneutrinos. That was a fairly recent discovery. And as we know, there's this belt around the Earth and the Van Allen belts, which show huge fluctuations, you know, sometimes. So again, it fits this picture of massive fluctuations and high energy electrons. So what I'm saying is that the same pattern can be seen on our planet as well. So something that's probably familiar to you. And here we see the discharge of electrons coming from the volcano itself. And a lot of people think the lightning is coming downwards, you know, but it's actually coming from the volcano. And did you see the sort of spiral plumes? So this is the lightning coming from the volcano. So again, volcanoes are saying is of the same process, the equivalent of a coronal mass ejection or a black hole ejection from our own planet. So that's why it's giving off the high energy electrons in the form of lightning. But the main thing I want to talk to you about in terms of the Earth is something we heard about earlier in this conference, which is terrestrial gamma ray flashes. Anybody heard of those? Well, you heard about it the other day, yeah? So as we heard the other day, these are actually just fairly recently found from the fact that we've got satellites way above the planet at the moment, and we found all these new types of lightning, such as sprites, elves, blue jets, and some of these are electrons that are travelling at the speed of light. And of course you also have gamma ray flashes, which were totally unexpected. We were not expecting gamma ray flashes in the Earth's upper atmosphere, but this is what we found. And the radiation of these are actually going at the speed of light, so the same sort of pattern. And it took NASA by surprise, and they actually ended up examining these. So, and lightning, just to say that, you know, if you read the textbook, the mechanism of lightning is that, you know, you have so much energy and charge created in clouds, but actually you, and then it discharges to the ground. Actually, the measurements don't fit that. So, this is the picture that I published actually in 2006 in my book Punk Science. And I said that what we should expect to see in thunderstorms is antimatter in 2006. And in 2011, well, 2010, NASA started studying thunderstorms, and in 2011 they published that they did indeed find antimatter in thunderstorms. So this is something that I did indeed predict, and and they don't really know why it's happening. You know, we don't really understand what's going on inside thunderclouds, but it totally fits the pattern that I'm saying. So to spell it out, this is just one aspect of what I'm saying. I'm proposing that the process behind black holes at the centre of the galaxy that creates gamma ray bursts, electron discharge and antimatter is the same process in thunderstorms, TGFs, that creates gamma rays, electron discharge and antimatter, and this process occurs at many other levels. Now by now you're probably getting what I'm getting onto, because there's something else that happens in thunderstorms, not all the time, but and it's rain. And I was really surprised to find out that the mechanisms of clouds, and Jerry's talked about this as well, is not fully understood. Why it is that some clouds rain and some don't. You know, I was taught in school about the water cycle and all of that sort of stuff, so I was quite surprised. So if I'm making a claim that TGFs are equivalent to black holes in space, but TGFs actually produce rain, then black holes have to produce water for me to be in any way correct. And I just kind of went, oh no, nobody's going to believe that black holes produce water. But of course, we since then have found out that black holes do indeed spew water vapor, and they do it in fine jets, you know, so from the actual black hole itself, so it's not from the surroundings. It's actually in concentrated jets from the black hole itself. And in fact, associated with the quasar, we have found the biggest pool of water in space associated with black hole, quasar black hole. In fact, as you probably know by now, water is quite common in space, and we see it in comets. I mean, comets we kind of expect to see water and ice, but what we're not expecting, this is the jet, is that the jet is so fine and it's coming from a very specific place on this comet in the middle. Okay, so you know, it's a concentrated jet, and we're seeing them on Jupiter's moon, we're seeing water, we're seeing on our own moon, you know. So what I'm saying is that the water is being produced by this process in the interior of these bodies. Okay, so what happens in the comet is that it's produced in this jet, and of course it freezes, and then we get the comet that is so familiar to us, which is these icy snowball kind of picture. You know, as I said, it was totally unexpected that comets had any ordered kind of emissions. People just thought comets were icy snowballs that melted when it got close to the sun, and then created a trail. They didn't realize that there were concentrated jets coming out of them. That was a big surprise. Another place you probably didn't realise that water came out of was sunspots. So there's water vapour that comes out of sunspots, and basically because it's a self-similar pattern, you're going, you know, at every single level, and the sunspots are also part of this self-similar pattern. So we see, you know, would expect, if my model have any merit at all, to see water coming out of sunspots, and indeed you do. And and also Mercury, which was thought to be too close to the sun to have any water at all, actually has water visible as ice. Actually ice within craters, and there's all sorts of ideas as to why this is happening. Back to the Earth again, and you know, this is an example. Well, so what I'm saying is that earthquakes and volcanoes are created by the same sort of process, and water, this is a rare video of liquefaction at an earthquake. So water just comes out of the ground. Do you know what the main gas of a volcano is?
Depends on the volcano.
Depends on the volcano, but the main gas, as the abundance of varies considerably, from volcanoes. However, water vapor is consistently the most common volcanic gas, comprising more than 60% of total emissions. Okay, so the ash cloud that I got stuck in New York with, it wasn't ash. There's not enough trees in Iceland to have created that much. It was water vapor that was causing that issue. It's the most abundant gas in volcano eruptions. So what we're missing from volcanoes at the moment is evidence of antimatter emissions. That, according to my predictions, that should happen. So that studies need to be done. I mean, we've got the geoneutrinos, but we haven't got that. So if I'm saying that this is the mechanism of the planet as well, how did water get to Earth? Now, honestly, this is been a debate for years and years, and many people, if you speak to many scientists, they'll tell you that asteroids and comets hit the planet, and there's lots of problems with this theory as in why it hasn't all disappeared by now. And in 2013, at the Institute of Noetic Sciences, I presented and said the water is coming from the Earth's core. So it's been continuously created from the Earth's core. And indeed, in 2014, a massive ocean was discovered near the Earth's core. Okay, so I'm saying this is the same process that's going on. So we've got some evidence of the same process happening on our own planet. You've got the water emissions, you've got the antimatter in terms of geoneutrinos, and you've got the GRBs in terms of the TGFs, so terrestrial gamma ray flashes. So back to Mars, NASA is saying we don't know where this is coming from. I'm saying it's been continuously created from the interior of Mars, and as a lot of bodies as well. And so the possible process, this is speculation here, is that as the photon splits into the matter and antimatter, it happens at in different ways at different levels of the universe, but the principle is quite similar, and there's lots of different adjuncts to it as well. This is highly simplified, but I think that's where water is produced for some reason. And I don't know the reasons. There's lots of gaps in this because lots more work has to be done. There's a lot of questions now. Why is this process happening so similarly at every level? And we'd have to investigate this a lot. So, and the implications that this really is happening at every single level is, is it happening at, has it got implications for easy water? We heard a talk the other day about ball lightning and energy sources, and the barrier to understanding this is belief. So why are we not using those energy devices? Because people don't know what's going on, basically. They don't believe it because they've got no mechanism. So maybe this work that I'm doing is going to help us to understand what's happening in those devices. And at a cellular level as well, I didn't go into that at all, but you've got DNA, light being given off DNA, the water burning effects that we've been discussing, the biophoton emissions, whether, a radical concept is, are lone clouds because they're actually mini black holes that are producing water. So have we got the water cycle, wrong in some ways? And understanding volcanic eruptions as well, which would have huge implications for humanity. I don't expect to record this table, but just a little, summary of things that have been going on. So what conventional theories have been surprised by, have actually, expected in some ways. And the conventional theories are saying that these are, high energy explosions. And, so what I'm saying is that this is the same process, and it's kind of like an elegant simplicity that's happening at every level, giving rise to infinite complexity. So there's this elegant simplicity that's happening. And I think that's what we're looking for in nature, not these burping, not these hiccups, but, this simplicity. So just to say that there are some physicists who having looked at the data and all these surprises that they're getting, are starting to question things like the Standard Model. So, you know, mainstream physicists as well.
I think we're at an interesting time where we're up against how perfect a model it might be. Maybe the Standard Model is wrong and we have to come up with a better model.
So that was part of a documentary on the BBC Horizon that actually was called What If Everything We Know About the Universe is Wrong? So just to say that when you look at the data and the fact that it doesn't match the theories and we're getting so many surprises, people are starting to wonder if we haven't, if we've not got it right, basically. And what I'm saying is that with this model that I'm proposing, you know, we can make more predictions and it's more elegant. So the elegant universe is that every single body is producing its own water at every single level. And once again, thank you very much for inviting me. And please have a look at my website, the movie website especially. And thank you very much, Jerry, for asking me here. Thank you.